based on the derivation of elliptic equation with Poisson type, okay, you have 5 points derivation. So now, okay, let's go to the step 3. Step 3 is to generate UIG. Okay, there are 3 points that we are going to find, okay, for elliptic equation. Okay, the first is, okay, how to find UIJ, U11, U21, U31 based on the equation of the Poisson derivation using finite difference method. Okay, we start with I equal to 1, J equal to 1. Why? Because we have the value at the boundary condition. Alright, so now let's replace, okay, U10 plus U10, UIJ, okay, UI minus 1J, and then UI plus 1J, minus 2UIJ, alright, plus UI plus 1J, plus UIJ plus 1, alright, equal to H squared exponent Y1, right? So here you have the boundary condition and initial condition you need to use, okay, the boundary condition 1, 3, and 4, right? So for example, UI0 is a U10 equal to Xi, X1. X1 is 0.5, right? U01 is a 0, so you put 0, and then U10 is a U12, okay, U12 is a U12 equal to Xi exponent 1, okay, so we put 1.359, okay, to get the solution, overall solution, but we don't know what is for U11 and plus U21. Right, the right hand side is a real number, so we collect all the real numbers to right hand side. That will contribute to equation 1, alright. Negative for U11 plus U21 equal to 1.653. This equation 1, this is the first row for matrix A equal to F. Now we continue to find I equal to 2, J equal to 1, the next grid, alright. So in this case, we want to find, okay, the linear system of equation where we involve, okay, I j minus 1 plus u I minus 1j minus 4uij plus ui plus 1j plus uij plus 1 equal to h squared exponent y1. Alright, so this is, we involve two boundary conditions, number 3 and number 4, where u20 is x2, x2 is equal to 1, and the other one is a u22 equal to x2 exponent. x2 is equal to 1 times exponent is 2.71a. Alright, so now we have a real number on the right hand side, so bring all the real number here to right hand side, and we left u11 minus 4 u21 plus 3 u31. This is a second order of the linear system of equation using 3 points. Okay, and then replace for another step, I equal to 3, j equal to 1. Okay, so you have 3 boundary conditions. Alright, the first is u30 equal to x3, the second is u41 equal to 2 times exponent y1, and the other one is u22 equal to exponent 2 x2 exponent. So that will be the linear system, okay, for equation number 3, boundary number 2, number 4. So bring on right hand side, you will get u21 minus 4 u31 equal to negative 8.256. Alright, so now this is will contribute to equation number 3. Alright, so you have 3 equations, number 3, number 2, alright, and number 1. So based on this equation, alright, so you develop a linear system of equation as following. Alright, this is the linear system equation. You want to find u11, u21, u31, and then this is the system of A. Like is a diagonal matrix, and then there is a boundary, there is a tri-diagonal matrix, and the upper and lower will be 0. And then this is a f on your right hand side. So this equation can solve using calculator, straightforward, or you, if the question asks you to use Gauss Seidel method, where we can refer in chapter 2, right? So generate a number of iteration for the grid U11, U21, U31. Okay, we have 3 grids here with the initial value given in the equation U not equal to 0, right? Ui j equal to 0 when iteration 0. So k is iteration, k generated, and then by using the Gauss Seidel, you already know how to develop a system linear of Gauss Seidel method, where the Gauss Seidel is depend on k plus 1, okay, and depends on the value k. However, U11 will be replaced a new U11 at the second grid. U21 will replace to U21 new at the third grid. Alright, so this is the Gauss Seidel method. So based on the table, the grid will be, the iteration will be stopped with the condition Uijk plus 1, the new iteration, minus the previous iteration, less than 0.005 for 3 decimal access calculation. Right? So now the answer is, okay, when the x equal to 0.1, y is equal to 0, when x equal to 0.5, y equal to 0.5, so the wave value is 0.825. When x equal to 1, y equal to 0.5, the wave value is 1.652. Alright, when x equal to 1.5 and y equal to 0.5 is the first step of the y, so the wave, the u is u 2.477. So when we draw the graph of uij, the graph is increasing, okay, when the x increase, right? So this graph is a curve, this is a wave, right? So this is a step number 6, okay, is to find the value. Step number 5, to solve using a linear system of equation. And step number 4 is generate the grid. And step number 3 is to process of generating using the derivation of the elliptic equation, of the elliptic